GATE 2012 Civil Engineering Question 42. A water sample has a pH of 9.25. The concentration of hydroxyl ions in the water sample is. The four options given are A. 10 raised to the power minus 9.25 moles per liter, B. 10 raised to the power minus 4.75 millimoles per liter, C. 0.302 milligrams per liter, and D. 3.02 milligrams per liter. The relevant NPTEL reference has been listed. Coming to the useful data, if we talk about pH, it is given as the negative logarithm of the concentration of hydrogen ions in a sample. If we talk about pOH, that would be the negative logarithm of hydroxyl ions concentration in the sample. So if we add them together, that is pH plus pOH, from equation 1 and 2, we would get minus log of H plus minus of log of OH minus. So this would turn out to be minus log H plus into OH minus. The product of hydroxyl ion concentration and hydrogen ion concentration in a sample is given as Kw, which is equal to 10 raised to the power minus 14. So this would become pH plus pOH equals 14. So the sum of the power of hydrogen and the power of hydroxyl ion in a water sample is 14. So in this case we have been given the pH of the sample as 9.25. Using this we can find the pOH, which will be equal to 14 minus pH. So that would become 14 minus 9.25, that would be 4.75. So using this we know that pOH is equal to minus log of the concentration of OH minus ions. So using this, the concentration of OH minus ions will be equal to 10 raised to the power minus pOH, which would become 10 raised to the power minus 4.75, and concentration is always measured in moles per liter. So none of the options in the question match with this, so we will try converting it to grams per liter or milligrams per liter as the case be. So 1 mole of hydroxyl ions will weigh 17 grams. This comes from the concept that the weight of oxygen is 16 grams plus weight of hydrogen is 1 gram per mole, so that would become the total weight as 17 grams per mole. So we know that 1 mole of hydroxyl ions would weigh 17 grams. So 10 raised to the power minus 4.75 moles would weigh 17 into 10 raised to the power minus 4.75. So this would become 3.02 into 10 to the power minus 4 grams per liter. This can be converted to milligrams by operating it with 10 cube, and it would become 0.302 milligrams per liter. The concentration of hydroxyl ions in the water sample is 0.302 milligrams per liter, that is option C. The relevant NPTEL reference has been listed.